Hello class. So we're going to start looking at combinational circuits. We're going to start off using AND, OR, and NOT gates. Okay, we'll start off pretty easy. Today we'll look at just basically a two-step combination circuit, and we'll involve a little bit of the Boolean expression. Okay. Don't forget your assignment from yesterday, the waveform. Don't forget to turn that in with today's assignment. Okay. Alright, so for today, here's a combination circuit. So you can see we have a AND gate and an OR gate. Okay. So this is a two input circuit. So we only have X and Y's. Now if you're wondering why this X down here, it's just easier to do it that way rather than trying to do another line coming off of X into here. That way you don't get multiple lines overlapping. So if you ever want to put, so X can go into any gate, or I can even add a Y and have that basically skip over this gate and then come into the second gate. So you can structure that however you need to. It just keeps it more, like I said, this is much more clear, put it this way, than trying to just draw an extra line off of X and coming back in here, especially as they start getting bigger and bigger. So you can just list them as many times as you need them. Okay, but these are the same X, so whatever X represents, it's the same thing. I just wrote it this way for simplicity. Okay, so A, what is the output after gate 1? So meaning with the output, in this case, since we're not given values, like if we knew X was 1 and Y was 0, then we can say, okay, well this output is on or off. So we're not looking at those just yet. That will be later on. Right now we're just looking at expressions. So when I ask what is the output after gate 1, I'm just asking what is the Boolean expressions. Okay, so basically we have X and Y coming into 1. This is the AND gate, so this means X and Y has to pass through. So you can write it like that, or whichever one. Okay, so only if X and Y is both on will this continue through. Okay, if X and Y is not both on, then basically the circuit stops here and doesn't continue. Okay, so if X and Y is both on, then it will continue on. So now we have an OR gate. Okay, so remember this was an AND gate. This is an OR gate. So now we have an OR gate. So what is the two inputs? We have X as an input, and then this input is whatever the output of 1 was. Okay. So we have an output of XY from gate 1. That is now the input for this one, and the input here for this line, well, that's just X. Okay, so the output of that, so OR gate, so it's going to be this or that. So XY or X. Okay, or if you wrote it using the other notation, XY or X. So what is the output after gate 1? It's just XY. And what is the final output of the circuit? So XY or X. So basically what that means is, so think about this, these are logic gates, so think about this logically. What that means is, whatever this system represents, okay, a lot of times it's easy to think of these as like an alarm system. So yesterday I gave the example of a reactor. If both reactor 1 and reactor 2 were too hot and the sensors came on, then that means the alarm came on. Okay, so in this case it could be something like that. So in this case, if both X and Y come on, then it will pass through. And then only if X and Y or just X. Okay, so that's the key difference, because X has its own input here. So if this was an alarm, so we could do something, so think of like from your circuits. Okay, this is like an alarm. So the alarm will sound if X and Y is both on, or just X is on. So that means if Y is the only thing on, then the alarm won't come on. So whatever Y is, it doesn't matter so much. But if X and Y are on together, the alarm will sound. Or if X is just on by itself, the alarm will sound. Okay, so that's what that means kind of in plain English. So these are logic gates, so that means they just basically mean, we try to write these expressions to try to mean what they mean logically, X and Y, but you can kind of think these out in terms of plain English. Okay, so if these two together are on, or if just X is on. Okay, but if Y is on, and Y is on by itself, then that's the only time the system or the alarm would not be on. Okay, so if I had asked you to explain this in plain English, that's basically what you would say. If Y is on by itself, then the system will be off. If X and Y is on, the system will be on. Or if just X is on, the alarm or the system was on. Okay, hopefully that made sense. Just kind of think about that. And if you have any questions on that, you can message me on Teams and I can go over a little bit further with you. Okay, so your assignment, this will be due not tomorrow, but it will be due on Thursday. Okay, so you have, not today, it'll be due tomorrow, so Wednesday. So I'll give you one day to do this. So you have, it's a combinational circuit. They're kind of similar, but instead of X, Y, and X, it's X, Y, and Z. Okay, so we have AND gate and OR gate. So tell me what the output after gate 1 is, what is the final output of circuit, and explain the final output, what it means in your own words. It's kind of what I did with the first one, but now I want you to give an example. So I gave an example of like the nuclear reactors yesterday. So just like that, you just make up a scenario just so I know that you can understand in plain English what these logic gates are trying to say. Okay, if you have questions, message me on Teams. If not, I'll talk to y'all tomorrow. Thanks, guys.